everybody. Let's get started. Nice to have a familiar face doing today's rough cut. I think a lot of you know Kelsey, who got his PhD here and is now the state climatologist operating out of U of M and assistant professor in the College of Forestry and Conservation. And he seems to be one of the busiest people in the state. I don't know how he manages all that he does. Kelsey's here, and we hope this is going to be a regular visit once a semester to fill us in on what's happening with the Climate Office. And it's motivated by the fact that we're doing a Montana climate assessment as part of the IOE EPSCoR Track 1 grant. And this assessment is focusing on 3 sectors in Montana. I think many of you are involved in this, focusing on agricultural lands, forest lands, and what's the other one? Water. Water. Yeah, and so we have
medium of change.
Faculty leading these efforts, and right now the climate assessment is in this what we call the listening session stage, where they're meeting with various stakeholder groups across the state and getting information on how Montanans want, how they use climate information, what are their needs, and how would they like that information delivered. And so this Montana climate assessment is going to sort of parallel the national climate assessment efforts, but it's going to be very stakeholder driven in providing Montanans with what they want to know to the best of our ability to do that in a credibly scientific way. So Kelsey is here to talk about the Climate Office's role, which is absolutely key and sort of forms the umbrella for how we're going to approach these different sectors. Thanks.
Thanks, Kathy. Well, I just say I'm really excited to be here today. Again, I do see a lot of familiar faces in the room, and it's kind of weird to be on the other end. A lot of folks in here were actually instructors when I was a PhD here, so it's interesting. I'm Kelsey Genso. For those of you that I don't know, I did my PhD here at MSU. I'm now faculty at College of Forestry and Conservation at MSU. I'm also a watershed hydrologist by discipline, so I'll just hold that card up right away and say that I am not trained as a climatologist, but one of the things to consider is that the climate of Montana is very spatially and temporally variable, and water is really the medium of climate change within Montana. I'm going to give a brief history today on the Montana Climate Office. For those of you who didn't know, it was actually at MSU up until around 1995 and run by Joe Caprio, who did a fantastic job. I'm going to talk about the Climate Atlas, the Montana Climate Atlas. The last time this was done was over a decade ago by Joe Caprio and others. So today's talk is more of a discussion of ongoing efforts and the evolution of the Climate Office over the course of the last 3.5 years, ending with the Montana Climate Assessment, our role in that, and how we're working to develop that to really, in a lot of respects, make sure that these climatological assessments are relevant for stakeholders in different sectors across the state. In terms of the Climate Office, the assistant state climatologist is Dr. Ashley Ballantyne, who many of you probably know. He is a bioclimatologist, global bioclimatologist, who focuses on quantifying uncertainties in the global carbon balance, and especially related to the fluxes of into and out of energy into and out of oceans and the CO2 that the oceans may be a sink for. Michael Sweet is our information services specialist. He's got over 30 years experience. He's trained as a forester, but he's also got a background in computer programming, and he's been doing GIS since that became a thing. Nick Silverman, Dr. Nick Silverman is a former PhD student with Dr. Marco Mendieta at UM. He has specialty in distributed hydrologic models as well as downscaling global climate models and projections. And we've been lucky and fortunate to hire him recently. He's also working on a project with Bruce Maxwell and the MSU Extension M-Ready project. So he's working on multiple projects. He's kind of a jack of all trades, but he's also working with us through funding from the IOE on the Montana Climate Assessment. Okay, So just a brief background on the Climate Office. We spent some time thinking about what a Climate Office exists to do. And our goal at the Montana Climate Office is to provide all Montanans with high-quality, timely, and relevant scientifically based climate information. There's a lot of climate information out there, and there are multiple entities, federal entities especially, that exist to develop that climate information. But one of the common conversations we've had since we've begun in the state is that there are so many disparate sources of this information that it's hard for people in the state, just the public, state agencies, and other stakeholders, folks like grain growers and operators, to really get a good picture of how climate is changing within Montana and which information they should trust. It's also difficult for them to figure out where they should go to access that information. And so we see one of our central roles as a Climate Office as an aggregator of climate information and the products, new climate data products that are being developed. But also, and amongst the universities, we see our role as testing and evaluating those climate products. Which ones work more or less, or which work well or don't work so well in Montana, given its complex spatial nature, east or west of the divide, and which should we have more faith in. On a day-to-day basis, we also spend a lot of time assisting different stakeholders in adapting climate products to their needs. So when I talk about a climate data product, something like precipitation or temperature, while that's a really important climatological variable, it may not be as relevant for, say, somebody in a dryland agricultural setting who needs to begin to understand degree growing days for a given crop, something like winter wheat or spring wheat or hard red wheat. And so we work to take, sorry, I like to move around. I feel like I'm in a classroom right now. And so we take these original data sets and we work with experts across the state to start to understand things like the phenology of our crops and how those may be related to growing season lengths for different types of crops. Okay? Just a quick history on our efforts in the last 3 years. So we are a state-designated body. In the last couple of years, we've been housed under the Montana Forest and Conservation Experiment Station. When we think about the Climate Office, we are a state climate office and state entity. And so we don't consider ourselves a University of Montana entity, even though we're based on the University of Montana campus or a Montana state. We consider ourselves part of the larger scientific community within the state that exists to provide information for Montanans. We're also an official member now of the American Association of State Climatologists, and so this happened last year. We regularly attend the ASC meetings and are part of that network. In 2013, the State Library and Montana Land Information Advisory Council designated our office, after a series of meetings and kind of proof of concept, as the official steward of climate information for Montana. So this is in Montana Code annotated 91. You can read the number. But what that means is that we aggregate climate information, and we're the steward for that information. We provide it on an annual basis, and that's housed and accessible by all Montanans through the State Library web portal. And I'll show a quick, I don't expect you to read this entire paragraph, but as part of the definition of a Montana framework, what do you have to do to be part of this framework layer? I will mention that we are the first state in the nation to actually designate climate as an official state data layer, which is pretty exciting. So progressive in that sense. The definition of a framework layer is a digitally formatted representation of land information features, both natural and cultural, that are coordinated, developed, integrated, maintained, and distributed through a community-based effort over a geographic area of Montana. And so for the remainder of this talk today, I'm going to highlight some of the aspects of the work that we've been doing that focus on the coordination, development, integration, maintenance, and distribution of climate information. Okay. So when we think about Montana, we are a headwater state. So we're at the headwaters of 3 major river basins. And when we consider the geographic area of interest for climate information, we consider that not only within the political boundaries, so counties within Montana, but all watersheds that intersect our boundaries and extend outward from Montana. So we try to collect the information on a larger scale basis. Okay? When we think about the dissemination and contributions of climate information, currently there are over 28 entities that receive federal funds to generate climate information. However, none of those entities specifically exist to provide that information in an easily usable context for Montanans. And so we see one of our major roles as aggregating that information and providing a one-stop shop, essentially, for climate information. We also believe that we should exist to create a dialogue between these entities, especially when that dialogue can facilitate and help Montanans. Okay? So we can think about climate and its variability across the state. It's highly variable, and we haven't spent a significant amount of time understanding how it does vary. We have historical records that we can start to do trend analysis for things like precipitation and temperature across Montana, but we haven't done that in a significant way yet. And so when we think about the medium of climate change in Montana, we're a semi-arid state, and really we might expect that things are going to become increasingly arid as temperatures increase and arguably precipitation either stays the same or increases slightly depending on what you look at. So when we start to think about quantifying climate change and variability historically and into the future, we need to think about the different sources of information that we can use to understand water and how it may vary across the state. So we can use a combination of weather data, topographic data, NASA-derived satellite data, and then large-scale atmospheric data. And so before we know how to manage, we have to know when and where our management activities are going to have the most impact. Okay? So to do this requires quantification of the spatial and temporal trends in climate across Montana, a development of user-oriented climate tools. We can't produce climate data and tools that nobody's going to access. It has to be housed somewhere, and there needs to be some conveyance mechanism for getting that out to folks who actually make day-to-day decisions and need that in their decision-making process. Really important is this dialogue between the climate product developers and the user community. We believe that information should not be a one-way street. We need this bidirectional exchange of information. As we develop products, we should be talking to user communities, grain growers, and the agricultural community, or water managers and users to understand how we put that information in a context that is easily ingestible into their workflow and that has relevance for their geographic area of interest, excuse me. And then finally, the distribution of that information. It needs to be maintained on a regular basis to continue to build trust and so that we have a regular flow of information. Okay? When we think about the climate information and data that the Climate Office is aggregating, it typically consists of both point-based meteorological data, so point-based stations from point-based meteorological stations that are recording things and variables like relative humidity, temperature, precipitation, soil moisture, etc. Some of those data sets extending back to 1905 for certain parts of the state, especially for the Global Historic Climate Network. We also aggregate that information as well as use NASA satellite-derived information to derive many other indices and measures of the spatial variability in climate, but also ecological processes within the state. And I'll talk about a few of those. Okay. For the meteorological data, we have just released an online and interactive version of the meteorological data. So now you can go to an interactive GIS web interface and click on and search either by county or address essentially across the state and download time series of all meteorological data that is aggregated across the state. Essentially all of this information comes with measures of uncertainty, so the data has been QA/QC'd, and we have metadata on site for each station. So this is updated on a daily basis, and we'll continue to do that into the future. So I've shown an example here of a station in the Helena Regional Airport. When you click on this point on the map, you get a description of all the variables that are being recorded at that site, and we're working on preliminary plotting so we can actually look at that time series over time. Okay? So having all of this information in one central location provides the means for a change analysis. We can now, and others, we can do this and others can do this, we can begin to aggregate this information and use it for historical change analysis across the state. So just an example, I've shown the mean of 5 coldest winter days for a station in Billings, Montana, and we can do that on a moving window basis, and we could do it for many different types of analyses. Okay. One of the issues associated with the existing meteorological stations in our networks within Montana is we have a lot, there are over 4,000, but there's a need for more well-developed stations. And part of this, and one of the critical needs that we've heard about across the state, and especially in the context of agriculture, is the need for soil water data, measures of soil water, wind speed, and evaporative fluxes in agricultural landscapes. And so briefly, I just wanted to point out, this is kind of putting on my research hat. As a watershed hydrologist, I work with Dr. Jahu at the University of Montana's Blue Wrecked Experimental Forest as part of both the NSF DEB project and a USDA AFRI project. We've developed affordable data loggers in the measuring things like relative humidity, temperature, sap flux, tree growth with recording dendrometers, and volumetric water content. But these types of affordable data loggers can be easily adapted and used in agricultural settings. And so one hope is to start thinking about providing these data loggers in an affordable way, either through manufacture by Montana-based companies like S&K Electronics, so that they're accessible to the general public and build a essentially distributed network of soil water content monitoring stations across the state. There are lots of people doing this, and I'll highlight there's nothing special about these data loggers. It just provides an affordable way of doing that. Yeah.
There are 4,000 monitoring stations across the state. How do they differ, or do they differ? What extent they differ from, say, those neon towers that still don't exist, but are
so your basic meteorological station is going to give you a measure of the energy balance that you can calculate, something like potential evapotranspiration or evapotranspiration. So you want wind speed, direction, soil water content, relative humidity, temperature. The neon towers, from what I understand, and I'm sure there are folks in the room that know this better than I do, but they also give you a measure of water vapor fluxes, so the actual transpiration and evaporation, the measure of water vapor in the air, as well as CO2. So they're much more expensive, and they require a lot more maintenance. Yep. And so I should mention those 4,000 stations. They're composed of a mix of RAWS stations, NRCS, snow-tel monitoring sites, and then National Weather Service stations and historic monitoring sites. So they're all widely varied in the variables, that they're measuring, and their data records vary in length and quality. Okay. From those point-based stations, we've also derived gridded raster data. So here I've shown an example of a new daily and statewide product for temperature and precipitation. This resulted from some of the work that Dr. Jared Euler, now, he used to be a PhD student with Steve Running. He developed this technique. If you're familiar with PRISM, it's similar to PRISM, but it provides estimates of uncertainty in the measurements. He tested that against PRISM, DayMet, and some other products and found that it actually tends to work better, especially at higher elevation sites where DayMet and PRISM tend to be more biased towards warmer temperatures. He also uses a homogenization technique, so it allows you to detect shifts essentially in meteorological records that essentially occur due to sensor error or the movement of sensors. And so he found that in a lot of the cases of the NRCS sites, they moved their temperature sensors about 10 to 15 years ago, and so there was a step shift in temperatures being measured, especially at the higher elevation sites. And so it resulted in a higher degree of warming than we might have actually observed. So this homogenization technique is used in all of our analysis to analyze the meteor. So this includes measures of quality and uncertainty from state evolution as framed at different geographic locations. You can start to analyze these by watershed or by county and get a sense for how things have changed historically. Okay. We're also using NASA gridded data sets. So this is work that came out of Steve Running's lab, and I'm sure many folks in here are familiar with this. But we have archived and downloaded and QA/QC'd the historic data records for things like the Normalized Vegetation Difference Index, the measure of photosynthetic activity and plant greenness across our landscape. It can also be used to derive phenology in our landscapes, so the shutdown and turning off of plants across our landscapes. We also use a enhanced vegetation index, which minimizes the effects of canopy background, below canopy background values. Another very important variable in Montana is evapotranspiration. I sat through the Governor's Drought and Water Supply Committee meeting last week and looked at around 50 hydrographs where we talked about the precipitation levels and the stream flow levels, and there was indication that, as most know, we had lots of precipitation, stream flow went up, but that precipitation and snowpack melted early, and we had essentially a loss of snowmelt runoff much earlier in the year, and we had a deficit in terms of soil moisture later in the year. This is when aridity increases and our evaporative loss is much more significant. And so in a lot of cases and in a lot of assessments, evapotranspiration is the elephant in the room. We see increased evapotranspiration with warmer temperatures during the growing season, and this provides a way of measuring this spatially across the state. Okay, another new index that we're using is a Drought Severity Index, or DSI. It's a relative measure of soil wetness combined with photosynthetic activity of plants. So it combines both the features of the plants and their activity as well as available moisture in the soil. And I'll show and talk about that just a little more briefly. So we've done this for the historic record, at least for the time period that MODIS has existed, so about 12 years now. Here I've shown just a sample of that for years 2008 through 2011. So this is an index that ranges in value. It can be negative or positive, and red values would indicate increased drought severity. Bluer values would indicate less drought severity or moist conditions. And so we can see that change over time. I'll point out that I've shown this as an annual average, but you can start to parse this up into weekly or seasonal time periods to understand how drought is changing. And so we think there's significant potential to make this an interactive product. Essentially, think about a measure of drought severity on a weekly basis with every pass of the Terra or Aqua MODIS satellites over our landscape. And this could be an interactive tool where you could zoom into parts of the state or type in an address and look at drought conditions in individual farm fields. And I've listed the publication for this. This was a mix of work between John Kimball's group at UM and Steve Running's group. Okay, so having this spatially available data also gives us a mean to start to look at geographic differences in these variables. So again, things like greenness, evapotranspiration, or drought severity. We can compare, and I'm not going to spend time talking about these distributions, but we can start to think about this based on a political boundary, so county by county, or watershed by watershed, or based upon different land use types. So Montana, and I've learned this over the last 3 years, Montana is really progressive in our ability to capture variability in land use, land cover, and agricultural settings across the state. We have one of the best databases for this. It's updated on a 3-year interval. And so these types of land use, land cover maps are really important for calibrating this type of satellite data. The images that I've already shown, that I showed for the drought severity index and evapotranspiration, they're based on a global biome type, so 7 different land cover classifications, and that's really coarse. To do this in Montana and to do it well, we need to consider the vegetation types at a much finer detail, as well as the meteorology. The input meteorology data for the satellite-derived indices is at a very coarse scale as well. So it's reanalysis meteorological data. So they do need some work, but I think there's significant potential for using them here. Okay, so we could compare between different land use, land covers, as well as across watersheds to understand how things change on a given time interval. Okay. One of the other things we've been working on, and this is work by Dr. Nick Silverman, he just worked on this recently. El Nino is the talk of the town right now. What's it going to do? Should I buy a ski pass at Bridger or not? There's been some faith put in the role of El Nino in terms of predicting whether we'll have higher than average precipitation or lower than average, or if temperatures are going to be warmer or lower. A big caveat to that is that our observations of El Nino really become more confident in the 50s. And so we don't have a historic record to go back and actually compare to our meteorological records in terms of this ENSO index. So typically in Montana, El Nino conditions are attributed to warm and dry conditions. La Nina are cool and wet time periods. Typically the most accurate measure of the current ENSO conditions, or of the ENSO condition, is this multivariate ENSO index. It takes into consideration spatial patterns of 6 different variables over the tropical Pacific. So oceanic temperatures, sea level pressure, zonal wind speed, meridional wind speed, sea surface temp, air temp, and cloudiness. And so altogether, they give us an estimate of the state of our ENSO conditions. We're currently predicted to be in a strengthening El Nino phase. Okay? So we essentially wanted to develop a tool and understand if there is any predictability for Montana related to ENSO conditions. Were we in an El Nino year or were we in a La Nina year? We aggregated and pulled together all of the historic meteorological data and parsed that between years of El Nino and La Nina. And then we made a map, essentially, maps of anomalies across the state. So this is online, and I'm going to highlight some of the big assumptions to this really quickly in a second. So you can look at combinations, and it's hard to see here, but you can look at precipitation, the phase of ENSO, so is it El Nino or La Nina, PDO, so a longer-term trend in ocean temperatures are also very important that occur on 10 to 20-year time periods. So what phase of PDO are we in? And then this can be evaluated based on season, winter, spring, and summer. And so you get a map of anomalies for these different variables. So in this case, I've shown precipitation for El Nino, warm PDO phase in the winter, and the darker colors here would represent a reduction in precipitation in meters, so up to 30 millimeters reduction associated with El Nino conditions. Okay, so big caution or question mark here. In a lot of cases, and for a lot of places in Montana, anomaly is actually less than the variability across El Nino, La Nina conditions. And so one of our big concerns here is that we don't want to release this until there's been a more robust evaluation of this map. We can begin to use it as our best first guess related to these conditions, but really we're working on a mask here to cover up sections of the state where the variability is actually greater than the anomaly that we observe. We shouldn't have a lot of confidence in that. And so for those of you in the room that are interested in this, I'd be happy to talk to you more, and we're looking for a way to better evaluate this and really say how much faith do we have in this. I'm not saying it's a good thing. Okay? Okay, so just to kind of segue. So with all the historic meteorological data as well as the gridded raster data, we began, and it gave us a starting point for putting together a new Montana Climate Atlas. It's essentially an assessment of historical conditions. This was done, we've done it for the entire data record, in some cases going back to 1905, but also for 30-year normals for these different variables. So again, all the variables that I've discussed and more. So it would take me an entire talk to cover all of these, and so I won't do a lot of that. I am showing a poster at the extension conference later today. I believe it's at 2:30, so I'd be happy to talk about the climate assessment or the climate atlas in more detail. Again, this is an interactive map, so you can click on this and you can actually zoom into these maps and type in by location or lat and longitude the location you're interested in for all of these different variables. We would like to work with folks across the state to think about other derivatives of precipitation and temperature that might be important, especially in terms of agriculture. And we're working with Bruce Maxwell and others to kind of evaluate and assess this climate atlas, but we'd love input from everyone else. Okay, So here's just a cookbook list of some of the common variables that we've included in the Climate Atlas. And here I've shown a map, the interactive map. It's in, again, an ArcGIS format. And so we include metadata on the maps as well as a description of each variable and how we assess those. So precipitation and measures of precipitation at seasonal and annual basis. Temperature the same, and then some ecological and agricultural variables for the data record that those information are available. So really excited about things like growing degree days, and I've just highlighted a few: spring and winter wheat, hard red wheat development. We also have had lots of phone calls lately from the viticulture groups across Montana. It kind of dawned on me there are folks growing their wineries appearing in the Flathead Valley and in other locations. There's actually one in Missoula now, and they're really interested in growing degrees days in the context of when conditions are suitable and where conditions are suitable for a winery. Okay. And the final topic, and again, I made this talk a bit shorter today because I wanted to open and leave time for discussion. So I wanted to talk about the Montana Climate Assessment. Kathy gave a good introduction to that effort. This is an effort being led by the IOE. It's in cooperation with the Madison River Group, One Montana, and then faculty at each of the universities. We're involved as and extension, thank you. Yeah, I meant to talk a lot about extension. We've been working pretty closely with extension and Bruce and others to. Extension is the boots on the ground and the way of getting this information to stakeholders that should have a lot of input in this process. I think that's one of the things that the group has discussed a lot, is that we don't want to spend a lot of time on a climate assessment that is not relevant to the state. And so we're spending a lot of time with workshops and stakeholder sessions to really evaluate what state agencies, as well as just producers, growers, local landowners for forest products really need across the state. And the same goes for water as well. And so I've kind of listed a timeline here. In our initial efforts, the Climate Office's role in this process, we're working on a development of climate projections. I would welcome feedback from this group and others in terms of the proper climate projections to use. We're considering a variety of different processes based on statistical downscaling versus physically based downscaling methods. Each of those comes with their own issues. From that, the projection development and an initial pamphlet in terms of how things may change in Montana, that will segue into an agricultural sector report, a water sector report, and a forest sector report. Again, in that entire process, we'll be engaging with stakeholders across the state. Okay, and ultimately, that will result in a Montana climate assessment. So I already described this, but we're working to develop a climate prospectus for stakeholder listening sessions. We're also, as part of this process, working to take the data that has already been aggregated and perform a historical analysis of temperature and precipitation by county, and probably more importantly by watershed across the state. Another important consideration is the evaluation of different global climate model downscaling methodologies. Which ones are more or less appropriate in Montana? And there has been work done by John Abatsgalu at the University of Idaho in this realm, and we're hoping to work with him as well as others. And then finally, a future change analysis across Montana by watershed and by county. So I'd like to talk about this a little bit more, and so I've moved through it quickly. But I'll just mention before I wrap up that all the information and data that I've described today is available and accessible on the Montana Climate Office website. It can be accessed as well through the State Library web portal, and there's access via direct download or through mobile devices. Thank you very much.
He's left a lot of time for questions, so.
Either that's a good thing or a bad thing. Adam?
The kilometer scale RASTER, are
They are available for daily data. So all of the analyses that went into the seasonal means, the annual means for the climate atlas, that was all derived from daily data. For the satellite data, there's absolutely not daily data. It's a weekly derived product because that's how often the satellite passes over and we have a swath across Montana. But for the temperature and precipitation, absolutely.
So say I'm a farmer.
Yeah.
And I am, there's a weather station 20 miles from me that I rely on heavily for my history of planting. And if I were to look at those daily rasters, if there was a medium put together where I can visualize readily the change in those rasters daily through time, so I can look at this location of a weather station 20 miles from me and my field that I'm interested in planting, will the rasters match the weather station?
Let me answer your question again, but I'll do it correctly this time. So all of the historical data is available on a daily basis. At this point, we don't have a daily map of things like precipitation and temperature. We do that on an annual basis. So we go back and look at the previous year's measurements, and then we do our interpolations based upon those. The pie in the sky and the nice thing to do would be to couple a methodology like the PRISM method for precipitation estimates with point-based stations, so we get a better certainty in those measurements. The other thing that I found interesting, the National Weather Service is now releasing their radar data on a daily basis, and they're archiving that. And so I think there's a really cool opportunity there to start putting that together as a statewide product. It's really great that they're doing that now. You know, on your note in terms of stations and relating a point in a field to a larger spatial data set, that can be difficult. And I think, you know, we can use precipitation and temperature and other proxies of moisture availability, but when it comes down to it, people really want the soil moisture data and measures of evapotranspiration. And so I think there's a strong need in the state for stations that would start to capture some of that variability and those values across the state. I think a few of you are in the room are familiar with the MReady project that was funded for MSU Extension and Bruce and others. Part of that project involves putting more stations out at the experiment stations, but also at 7 off-site farms, and developing decision-making models based on meteorological inputs as well as just current economic conditions and crop cover, et cetera, but new decision-making models based on that using a Bayesian approach.
Atlas figures I was speaking to some ag water managers last week, and I showed them some of the climate atlas figures and asked them about utility and interest in the data, and they were very receptive and interested in it. And some of the comments that came up were if we could look at precipitation across fields and or temperatures, then they could think about plant dates and stuff like that. So it's a follow-up conversation to have, how we could deliver that information to.
Yeah, I mean, so it's a really interesting topic. You know, originally, and my thought process on this has changed over time, actually, after I actually meet with groups that are doing and adding that extension component. It's one thing to develop all these great information and data sets, but it's another thing to actually get that into the hands of people who are going to use it and make decisions. And I think that's where things like MSU Extension and all the watershed coordination councils across the state can really be utilized. They have a built trust and a linkage that goes way back with those communities. And so I think it's really important. Rob? Oh, yeah.
So every time I see talks about climate data, I always think, well, shouldn't we be building some statewide watershed models? If we're actually going to make decisions based on this water availability, then that has to be like that with some kind of watershed modeling that helps make this decision. Do you see any direction,
That's a good question.
potential momentum going in that direction for state funding or anything like that?
Well, we did our PhDs together, and so you know my background, and I tend to think of all watersheds as different, and so I don't in terms of a statewide hydrological model, I don't know that there's one silver bullet, but I think you can add
models around the state to characterize particular landscapes.
I think there are a lot of, and in my discussions with folks like the DNRC, Bureau of Reclamation, and then Wyatt Cross's effort. Wyatt, are you here? Oh, lucky him. His effort in the Montana climate assessment, we've been talking a lot about the ingestion of the forward projections and predictions of climate data in a hydrological model. And so I think there's that aspect, but I think, yeah, there is a significant need for a statewide watershed modeling effort, and places like, I hate to say the word in here, but California are doing that and doing it well in terms of their water management efforts. So I think they're a framework that we could follow. Tim.
So in your first comments, you were talking about climate change and its projected model impact on Montana. What are the ranges in terms of temperature and moisture? And what kind of, I mean, where's your bias? Presumably you spend time thinking about this pretty hard.
Yeah, well, I guess what I'd say is my bias is in the spatial variability. I think we tend to think about the change across Montana as an average change. And so rather than telling you a range of temperature precipitation, I'll say precipitation is anticipated to go up slightly, but the projections in precipitation are highly uncertain, and that change in precipitation is pretty insignificant relative to the better certainty we have in temperature changes. So temperature is expected to go up. I didn't show a slide, but we've done an analysis for an average change of temperature across Montana as a whole, and we're changing, or we have changed in the last 30 years by about a degree more than the rest of the United States. So we're changing a bit more rapidly, and that becomes really important thinking about water availability and evaporative loss of water during the growing season. And so I guess what I'd say is my bias comes into play when we think about an average condition or an average value of temperature or precipitation. That's an average for a very large and topographically complex state where there are a lot of different causes of our climate variability. And I think we need to better understand and incorporate those mechanisms of variability if we're going to start to understand how that temperature change or precipitation gets distributed back into space. Some places are going to be warmer, some places are going to be cooler, and we need to understand what drives that response. Yes. Yeah, so, I mean, one example, starting this position that I always hear about is up on the High Line. They're having great growing conditions lately. It's been really wet. In some cases, they're limited. And correct me if I'm wrong, but they're limited. They can't even get into the fields because they're so saturated. But growing conditions have been really good recently, where other regions of the state have been really poor and dry.
Seems like in the listening sessions there's a couple of threads or similarities that are coming out of that. And so one is that people want really spatially precise information,
Yeah.
almost to the point where it seems impossible.
Yeah.
And so I wonder if you can talk a little bit about that. And then the other is, and kind of surprised me, that people are more interested in climate trends going back than they are in climate projections going future.
I think to address your second question, I mean, my thought about this, and I'm increasingly thinking more about the social aspect of climate change when I think about the science that we're trying to do as basic scientists in climatology or hydrology. I think the historical record, that's typically based on observations, and it's hard to argue about observations. But when we start thinking about moving forward, there are a lot of social structures that are influenced by anthropogenic causes of climate and divergence in our climate signal due to carbon emissions. And so I think it becomes a more difficult and less tangible discussion, especially when money comes into play.
I would also think people know how to respond to something that's happened in the past.
Yeah, our perception and our association with things that have happened in the past. We're closer to that, and we understand that. Yeah.
And what about the spatial precision, which seems like it's going to be a problem for us if that's what everybody wants and probably things can't deliver?
Yeah, I think there's some lower limit to how far we can go. We're not going to have a climate prediction at the scale of individual fields or even small watersheds in Montana, and so there is some limit, and I think this is a good first step to help us at least make a decision and understand how broadly across Montana things will change so that we can start an active discussion on adaptation and resilience to potential changes. I think we need to at least get to that point before, and then think about new methodologies, and I think this can be a process that continues. This isn't the first and only go-around. We're going to continue this as technology and science gets better, and as we get a better grip on, or a better handhold on what people in the state are really asking for. Sam.
So you mentioned that the future temperature prediction data has maybe, we have better confidence in that than we do for the precipitation data. I'm wondering if there's enough precision in that projection to show difference between the global emission scenario projections that, for example, the IPCC reports have been sort of focusing on. Mm-hmm. And if that shows any either different mitigation strategies or some compelling evidence for Montana advocating for one emissions scenario or another.
You mean Montana would use one emission scenario and the rest of the world would use another?
No, I mean Montana is a small piece of the pie in terms of global emissions, but at least in terms of understanding, my question is whether those future projected temperature tools can give us a perspective of the difference between the different emissions scenarios.
So I think they absolutely can. I mean, so part of that process is to consider the different emission scenarios. So we don't want to just pick one because we don't really know how people are going to make decisions and how we're going to change our lifestyles. And so we need to use an ensemble of emission scenarios to really get a kind of a broad spectrum of how things may change. And I think we'll try to, in this process, this is something I'd be excited to talk about with folks in the room, but which emission scenarios to use to capture kind of what we believe would be a representative response. Dustin. Sorry. You next.
I have a data layer request. My own curiosity. If you ever have a chance to work with social scientists, you should get wouldn't it be cool to have a map of people's perception of historical climate? And because you have those atlases of like how climate changed in the state. The highline's been really wet, or the big hole's been really dry. It'd be cool to see like how people's perceptions of that make up.
I think Liz Shanahan had to leave, but we've talked about that in the past, and I think that's a really exciting subject. So you have kind of this a measure with a given level of certainty, right? We could consider this an actual condition, and then we have people's perceptions of those conditions from the past and how closely do those two align, and how is that gap between those two influenced? How is the gap between a person's perception and that actual known value, how is that influenced by their geography, their day-to-day activities, their political backgrounds, their social backgrounds, et cetera? Can we use that as a management tool to understand where to focus our efforts within the state? Like, how do we convey these issues and needs?
Yeah, having all that data in one place is really easy to access.
Yeah, that's a really good idea. I'll talk to Mike Sweet and ask him to get started on that. I have to go with Anna next.
You work with a variety of people across the state. So how do you, or how does the climate office explain the difference between climate and weather?
Good question. Weather is what we experience in our day-to-day lives, and when we go to the bus stop and talk in the morning about whether it's going to rain or not. That's weather. Climate is just the long-term behavior in terms of seasonal and annual precipitation temperature. It's what we observe over a long-term basis. Well, the kind of standard, which I tend to not agree with this as much anymore, but the standard is 30-year. Yeah, so typically we evaluate climate on a 30-year interval in terms of what we call normals. I think given our knowledge of how things are changing, as well as just the larger teleconnections within our climate systems, things like the Pacific Decadal Oscillation, the ENSO, I think there are other ways that we could evaluate climate and parse it up.
Maybe one last question, Rich.
Rich.
Yeah, some state climatologists sort of in very high-profile ways been dragged into debates about climate change. How do you stay useful without getting fired?
So can we
have any more stories?
Can we cut this answer from the online video? I'll just say that my last 3 years have been a really, really eye-opening experience. I've gone to the legislature 4 times now and have testified in front of the Natural Resources Committee and for a couple of bills that were coming, that actually came out of Bozeman via Mike Phillips. And it's been an eye-opening experience, and I've really learned a lot. I've also, from that experience, coming out of a basic science program, I've really realized the need for the social science and how people's backgrounds really influence the politics and decisions that are made within the state. There are horror stories, and it's a challenge, and I think really the direct way to address climate in Montana is how does it affect our lifestyles. If I can give you a better guess on what things are going to do if you're a farmer, and I can tell you how things may change in 10 years and that you might need to consider rotating crops or adjusting to a different crop or a different species with a different genetic background, then that's a decision that helps you in your life as well as puts money in your pocket. And I think the medium or the proper conversation in Montana in terms of making progress for addressing climate change is Montana's economy and how it benefits. That discussion, an open discussion, helps us benefit in our daily lives. It was a bit jumbled, but good question. And I'm not going to tell you any horror stories. Maybe on the phone later.
Well, Kelsey, thanks very much. It's been great. We will continue the climate conversation next week. We have David Battisti here from the University of Washington talking about the little ice age and was it created by humans or something else, and are we out of it? No, Dave?
No.